Alright, so we're going to do two things in this video. We're going to graph inequalities, and then we're going to be given a graph and we're going to write the inequalities, and along the way we're going to identify some key properties. Alright, so let's do this first one. This looks like a quadratic. So we've got no horizontal movement because there's not an x, minus or plus something in here, so it stays on the y-axis, but we do go down 5. So let's go down 5 and put our vertex right here. And I'm going to just go ahead and write that in at 0, -5. We have a stretch of 2. So we go over 1, instead of going up 1, we go up 2. And then go over 2, normally it's up 4, so we're going to go up 8. 1, 2, 3, 4, 5. And then over here, and I don't think we get the next one, 1, 2, 3, 9, 18, we can't get that in. This is a dashed line. I know that it's going to be really high. The further I go to the right, it's going to be really stretched. So I can draw that in there. It says greater than, so there's two ways we can do this. We can know that greater than means in here, but if that's a little bit tricky, then all we need to do is test a point. If I test a point 0, 0, now if I've done my math right, then it should work when I put it in here. So 0 is greater than 2 to the power 0 squared minus 5, which is just 0 is greater than -5, which is true, so where we've shaded is correct. Axis of symmetry is x equals 0. Okay, let's do this next one. This is an exponential function. It's in fact a growth function with base 2, which means that we double as we go to the right. So let's look at our transformations. This tells me that I go right 2 and down 7. So there's my translated origin, which is basically what the beginning has moved to. So I've dealt with this part and this part. I'll have a look at now is it's going to get doubled each time it goes to the right with a stretch of 3. So that means our first movement here is going to be up 3 before we do anything else. Normally it's up 1, but we're getting stretched by 3, multiple of 3. So normally we go over 1. This is a base 2, so we'd go up 2 normally, but we get multiplied by 3. So 2, 4, 6 takes me to here. I go 1, 2. 2 squared is 4. 4 times 3 is 12. So that's 6, 7, 8, 9, 10, 11, 12. If I go to the left, this is 3. If I get doubled each time when I go this way, then I get halved as I go to the left. So that means 3 becomes 1.5. Etc., etc. This is a dashed line, so I know that it's going to go like this somehow. It's less than, which means I should shade beneath. I can check, put 0, 0 in. I have 0 is less than 3 times 2 to the -2 minus 7. That's 3/4 minus 7. This is not true because that 0 is not less than a negative number, whatever that happens to be. Therefore, we've shaded in the correct place because 0, 0 was not true. Domain is going to be all real numbers, so -infinity to infinity. Range is a tricky one. The lowest value is -7, but it is not included because it never touches this horizontal asymptote and it goes to infinity. So just be careful. Parentheses versus brackets. Alright, so these next 4 graphs, we are going to just write the inequality. Oops. Write the inequality for each of these following graphs. So there are 2 points here. I am personally going to use this point to help us do it. It's linear. Transformationally, I went x plus 1 and we went up 2. Let's see what the slope is. 1, 2, 3, 4, 5 over 2. So it becomes 5 halves. This is a dashed line and it's above, so f of x is greater than 5 halves of x plus 2 plus 2. Notice this is linear, so there's nothing on the outside here. It's not squared, square rooted, etc., etc. Alright, this next one, this is an exponential. This looks like it's a decay, because if I think about a decay, it goes down to the right, and a reflection would look like this. So, we have, I'll figure out the base in a minute, but we have x plus, looks like 3, and then on the outside here I have up 7. I know my a value is always this piece here, so that's going to be 2. I just have to decide what the base is, and the base I find from this next value is a times b, so that's 1, 2, 3, 4, 5, 6. That was 2, so then this must be, b must be 3. And we're going down the way, so I have to make it negative as well. So let's just double check. We moved left 3, up 7, stretch of 2, and then base is 3. This time, I forgot, this is going to be less than, squeeze that in there, less than, because it's below. Alright, 2 more. Alright, so this one we've got an absolute value. And right off the bat, to me it looks like it's above, so I'm just going to go ahead and do it. Notice that for these, because of the practice, I've not put any with greater than or equal to or less than or equal to, just because they're easy enough. I want to make sure that we have the dashed part taken care of. But do not forget, if it's a solid line, you have to put that equals part in as well. Okay, so we go absolute value of x, and this is going to be left 5, so plus 5. And then we go up 9, it looks like. And then I see a down 3 over 1, down 3 over 1, looks good to me. So negative 3 is your slope, and that one's done. Square root function, so I need a square root in here. I have x going to the left 9, so plus 9. Looks like it's down 7, right here. And then I can see over 1 normally up 1, but this is over 1 up 3. And that would be less than. And that's us done.